Hello and welcome to this course. In this course, you will learn to train object detection models on your custom datasets, and then you can use those models inside Android with both images and the live camera footage. Apart from that, you will learn to integrate existing object detection models inside Android applications. So we will learn to use SSD MobileNet model, EfficientDet models, and the YOLO model family inside Android with both images and the live camera footage. So the course is divided into three main parts, and the first part is about training custom object detection model. Then in the second part you will learn to integrate that model inside Android. And the third part is about using pre-trained object detection models in Android. So if you are someone who wants to train and use object detection models in Android, then you can take all three parts of this course. And if you are an iOS developer, then you can just take the first part and learn to train a custom object detection model for iOS. But the integration of that model inside iOS application is not included in this course. And if you are a machine learning engineer who want to integrate his existing object detection models in Android, then you can also take this course. Object detection is a computer vision technique that allows us to identify and locate objects in image or video. And in real world, it is being used for a variety of use cases like video surveillance, crowd counting, anomaly detection in agriculture and healthcare, and inside self-driving cars. So we can use the power of object detection and build smart Android applications. The first part is about data collection and annotation. And in this part, we will learn to collect the dataset for training an object detection model. After that, we will learn to annotate that dataset using RoboFlow and other such tools. After that, we will learn to train our object detection model using the dataset we collected and annotated. After training the model, we will test it to check the model performance and accuracy. Then we will convert this model into a TF Lite format so that we can use it inside our mobile applications. After training the model and converting it into a TF Lite format, we will learn to use that model inside Android with both images and the live camera footage. Apart from training our custom object detection model and using it inside Android, we will learn to use existing object detection models inside Android with both images and the live camera footage. So in that section, we will explore three popular families of object detection models and use them inside Android applications. And those families are SSD MobileNet models, EfficientDet models, and the YOLO model family. So after completing this course, you can train object detection models on your custom datasets and use those models inside Android applications. Apart from that, you will be able to use existing object detection models in Android and build powerful applications. The course also comes with the ready-to-use codes. So if you want to use existing object detection models inside your applications, then you can take the pre-built codes available in this course and customize them based upon your requirements. And for your safety, the course comes with the 30 days money-back guarantee. So you don't have anything to lose here. So what are you waiting for? Join the course now and start training your object detection model for Android. Welcome to this lecture. In this lecture, we will cover some basic introduction of object detection and its use cases. So, what is object detection? Object detection is a computer vision technique that allows us to identify and locate objects in images or video. For example, if an image contains two cats and a person, then with object detection model we can detect all these three things at once. So when we will pass this image to our object detection model, it will gonna detect that two cats are present inside this picture along with the person. And our model will also gonna return that where in the image these objects are present. So using object detection, we can get the things present in an image along with their location. Object detection is mostly confused with image recognition or image classification. But there is a big difference. Image recognition assigns a label to whole image. For example, if we pass this dog image to our image classification or recognition model, then our model will gonna assign label dog to this whole image. Similarly, if we will pass a picture where two dogs are present, then our image recognition model will gonna still return the label dog for that image, because that model assigns the label to the whole image. On the other hand, when we will pass this picture to our object detection model, our model will gonna detect that where in this picture the dog is present. And similarly, if we pass an image with two dogs, then our model will gonna detect that two dogs are present, and it will gonna also show us the location that where those dogs are present. So in that way, object detection provides more information about an image than image recognition. So hopefully you got the point that what is the difference between image recognition and object detection. Image recognition assigns the label to the whole image. On the other hand, object detection model draws a box around each object and assigns a label to that box. So there are a number of use cases and applications of object detection in real world. And some of them are video surveillance, crowd counting, and anomaly detection. In video surveillance, object detection model can track multiple people at once in real time. So it can be used in stores and factories for security, worker performance and safety, and for measuring retail foot traffic and more. So object detection can be used in stores and factories for smart video surveillance. Crowd counting is another valuable application of object detection. For densely populated areas like theme parks, malls, and city squares, object detection can help businesses and municipalities more effectively measure different kinds of traffic. And that traffic can be on foot, in vehicle, or otherwise. So using object detection model, we can count the number of people. So it can be used for measuring that how many people entered in a theme park, mall, or in a city square. And later that information can be used for various analysis. Anomaly detection is another use case of object detection which can be applied in agriculture and healthcare. In agriculture, we can use object detection model for detecting plant diseases. And this will gonna allow farmers to take in-time actions and increase their crop yield. And in healthcare, object detection could be used to treat conditions that have specific and unique symptoms. One such example is treatment of acne. An object detection model could locate and identify instances of acne in seconds. Similarly, it can be used for detection of tumors in human body. So apart from above mentioned sectors, object detection can be used in different sectors of human life. And in this course, we will learn to train our custom object detection models, and then we are gonna build smart Android applications using those models. So hopefully you will be excited to learn something new and valuable. Welcome to this lecture. In this lecture, we will see how an object detection model is trained. As now we know that an object detection model can recognize the things and also locate the position of those things. But how we can train our custom object detection model? So suppose that we want to train an object detection model to recognize several fruits like watermelon, pineapple, kiwi, and apple. So to train this model, we firstly need to collect images of these fruits in different scenarios. And that process is called data collection. So in data collection, we collect images of the objects which we want our model to recognize. So in our case, we will collect 100 images of watermelon, pineapple, kiwi and apple. And after collecting the data, we will take each image one by one and draw a rectangle around each fruit and assign a label to it. And that process is called data annotation. So after collecting the data, we need to annotate it, and for annotating, there are several online tools using which we can easily annotate the data. And it is necessary to annotate the data so that our model can learn where an object is present in the image while training. And after dataset collection and annotation, the next step is model training. So in this step, we will take our annotated data and pass it to our machine learning algorithm, and we will get our trained machine learning model. So in our case, this machine learning algorithm will be a Python code using which we will train our model. So we will pass our annotated data to this algorithm and we will get our trained model. And now we can test this model so that we can check whether our model is accurate or not. So what we are gonna do is to pass some sample dataset or some sample image to this model, and this model should detect the objects present in that image. Like in our case, when we will pass this apple image to this model, it should return the label apple along with the location of this apple in this image. And that process is called model testing or model evaluation. So after training and evaluating our model, the next step is converting this model into a Lite format so that we can use it inside our Android application. And that process is called model conversion. And using Tensorflow Lite library, we will convert our model into a Lite format. So once we will get our Lite model, we can use it inside Android application with both images and the live camera footage. So we are gonna build two applications in that section. Firstly, we are gonna build an application in which user will be able to choose images from gallery or capture images using camera inside Android. And then we will pass this chosen or captured image to our object detection model, and our model will gonna return the results. And then based upon the results returned by the model, we will draw the rectangles around detected objects. And secondly, we will build a real-time object detection application in which we will use our model with the live camera footage. So we are gonna detect these fruits using the live camera footage. So the whole process can be divided into 5 major parts: data collection, data annotation, model training, model evaluation and conversion, and finally building our Android applications. Welcome to this lecture. In this lecture, we will start the first part of our model training process, and that is data collection. Data collection is a process of collecting data for training machine learning models. In case of object detection, this data is in the form of images. So we need to collect images of the items that we want to detect. Like in our case, we want to train an object detection model to recognize several fruits. So we need to collect the images of those fruits, and that process is called data collection. There are several ways to collect the dataset. The first one is that instead of collecting the images by ourselves, we will take some publicly available dataset. So we can take an entire dataset and train our model on it. Or we can just take the existing images of those datasets and annotate them by ourselves and then train our model. So the first way is use an existing dataset. The second way is web scraping. In that process, we will write some scripts to collect the data automatically. So we don't have to capture or download the images from Google one by one. We can just write the scripts and collect the images of a particular type. And the third way is taking the photographs. So in that way, we just take a camera and capture the images by ourselves and form our dataset. So that's the third way that we will collect the entire dataset by ourselves. And the fourth way is data augmentation. It is actually a data processing step instead of a data collection. So in data augmentation, we will take the existing images of a particular dataset and we rotate and scale them and form new images. And this process is called data augmentation. So by that way, we can increase the number of images inside our dataset because we will rotate and scale the existing images and increase the number of images inside our dataset. So these are the 4 common ways to collect our dataset. And here are few things to remember when collecting images. The first thing is the size of the object in the images. So our dataset should contain both small and the large images of the object. If an object is usually large in the dataset, then our model will perform worse in the cases when the same type of object appears small. So it means that when collecting the images for our dataset, we should choose such images where the object is being appeared both in smaller and larger size. If our dataset only contains the images where the object is present in large size, then while testing the model, our model will not gonna perform well when the object appears small in the testing image. So it means that while collecting the images for our dataset, we should select the images where the object is appearing both in small and larger size. If all the images contain an object in larger size, then our model will not gonna perform well for the smaller size. And same is the case with the smaller size, like if we collect all the images where the apple is being appeared small, then our model will not gonna perform well when the apple will appear large when we are testing the model. So that's the first thing to remember when collecting the data. The second thing is the number of images. There should be around 150 to 500 images of each class to get good results while training the model. And if the images for a particular object is less than 150, then we can perform data augmentation and we can increase the number of images for that object automatically. And the third thing is avoid diagonal items. Diagonally positioned objects, especially thin ones such as a pen or road marker, will take up a significantly smaller bounding box area than their surrounding background. So it means that we should avoid the images of the objects where the object is being positioned diagonally, because when we will annotate such images, then the bounding box will gonna take a lot of extra space, like you can see in the image, that the bridge is present at a very small area as compared to the background. So this will have a negative effect while training the model. So we should not collect such type of images. So these are the things you need to keep in mind while collecting the data. And inside our next lecture, we will start the data collection process for our fruit recognition model. So, see you in the next lecture. Welcome to this lecture. In this lecture, we will start the data collection process for our fruit recognition model. So as we learned inside our previous lecture that there are several ways to collect the data. So one way is to collect the images by ourselves, so we can either capture the images by ourselves or we can take the images from Google one by one. But this thing will gonna take a lot of time. So instead of that, we will stick with the first approach, which is using an existing dataset. But keep in mind that we will just use the images of an existing dataset, but we will annotate them by ourselves. So the question is from where we can get existing datasets, and one such site is Kaggle. Kaggle is the world's largest data science community where you can find free resources related to data science and machine learning. So open your browser and type Kaggle. Click on the first link, which is this kaggle.com. So that is the home page for Kaggle, and here you can search for data science related materials. As we are looking for a fruits dataset, so we can type fruits in the search bar. So I'm gonna type fruits. And similarly, if we are looking for a movies dataset, then we can type movies there. And here in the results, you can see several tabs. The first one is notebooks. So there are more than 2400 code notebooks where fruit is mentioned. Similarly, there are 215 datasets which are related to fruit. So just click on this dataset tab so that we can see the list of datasets. So now you can see all the datasets here, and the minor details are mentioned, like when this dataset is published and what is the size of that dataset. So you can scroll down and see these details. Similarly, if you further want to look at the details, you can click on any of the dataset. Like in our case, we will use this fruits and vegetable image recognition dataset. So just click on it. And here you can see several other details like what are the classes or what type of objects this dataset contains. So there you can see that this dataset contains fruits which are banana, apple, kiwi, orange and so on. And it includes the vegetable like carrot, onion, potato and so on. Similarly, you can see the number of images for each class. So there are 100 images for training the model for each class, 10 images for testing the model after training, and the 10 validation images which will be used to evaluate the model performance while training. So these are the three things and we will explore them further later. So the dataset looks good and include all the 4 classes for which we want to train the model. So it includes this kiwi, watermelon, pineapple and apple. So we will use it. So after you will verify the detail of the dataset and you want to use it, you can simply download it by clicking on this download button, and it will gonna ask you to attach your Facebook or Google account with it. So here we will attach our Google account, and you can do the same, or you can either sign in using your email, Facebook or Yahoo. So we will use our Google account. So after attaching your Google account, you can click on the download button again and the dataset will start downloading. So here you can see that the dataset downloading started. So now let's wait so that our download will complete. So our dataset is downloaded, and now let's firstly unzip this zip file. So the extraction completed, so let's firstly visit this folder. So there you can see that there are 3 folders inside it, and the train folder contains the images for training, the test folder contains the testing images, and the validation folder contains the images which will be used for validating the model during training. So firstly let's look at our training folder. So there you can see that it contains separate folder for each type of object which is present inside this dataset. Like this apple folder contains all the images of apple. So you can look at these images for training the model. Similarly, let's explore another class. Like we will open this watermelon folder, and it contains all the images of watermelon in different scenarios. Similarly, the third class we will use is pineapple, and you will find this folder here. So let's open it. So as you can see that it contains all the pineapple images. And the fourth class we will use is kiwi. So let's look at the images for kiwi as well. So there you can see the kiwi images. So these are the 4 objects for which we will train our fruit recognition model. And if you want to include more objects, like you want to train the object detection model on 10 fruits, then you can choose more classes from here. But for now we will train the model on these fruits, this apple, kiwi, pineapple and watermelon. So for now we will delete the other folders. So I'm gonna select them all, and then I'm gonna unselect this watermelon, pineapple, kiwi and apple, and we are gonna delete the extra folders. Similarly, we will do the same for the validation and the test folder. So we are gonna select them all, and then we will unselect our watermelon, pineapple, kiwi and apple, and then we will delete the remaining folders. And finally for the test folder. So now we just cleaned our dataset and we removed the extra classes. Similarly, if you want to include some more images, you can take those images from Google, or you can capture the images by yourself and you can include them inside our dataset. For example, you can include the images inside this training folder, like the images for the apple will go inside this apple folder and the images for the remaining objects will go inside their respective folders. So here our data collection process is completed, and the next thing is annotating the data so that we can use it for training our object detection model. And we are gonna start that process inside our next lecture. But for now, we just downloaded the dataset from Kaggle and we explored that dataset that it contained the images of the respective fruits. So now inside our next lecture, we will start the data annotation process. So see you in the next lecture. Welcome to this lecture. In this lecture, we will start the second part of our model training process, and that is data annotation. For training an object detection model, we need a dataset, and the dataset consists of images for training an object detection model. So as a first step, we collected the images of those fruits, and the next step is annotating that data. So in data annotation, we take each of the collected image and draw a rectangle around it. After that, we assign a label to that rectangle based upon the object present inside it. So for an image which contains an apple, we will draw the rectangle around that apple and assign a label apple to it. And we will do the same for watermelon, that we draw a rectangle around it and assign a label watermelon to it. So that process is called data annotation. So while annotating the data for training our object detection model, we need to keep several things in mind. The first one is pixel perfect tightness. So it means that we should draw the rectangle or the bounding box around an object in such a way that the edges of bounding box should touch the outermost pixel of the object that is being labeled. So that's the first thing you need to keep in mind. The second thing is about data collection, but it is also relatable to data annotation, that there should be both smaller and the larger images of an object should be included in the dataset, so that our model will be trained effectively and it will perform well both for the small and the large occurrences of the object. So for smaller apple, the bounding box will be small, and for larger apple, the bounding box will be large. And the third thing is again this diagonal items. So we should avoid the diagonal items, because in that case, when we draw a bounding box around that item, the background is included in larger proportion. So as you can see in case of this bridge, the bridge area is very small and the background is very large in the bounding box. So this will gonna give this can affect the performance of our model while training. So we should avoid such images where the object is present diagonally. So now the question arises how we will draw the bounding box around the images. So in this course we will be using RoboFlow for annotating the dataset. RoboFlow is a computer vision developer framework for better data collection and annotation. So we can just upload our dataset on RoboFlow, and then inside RoboFlow editor we can open the image one by one and draw a rectangle around each object and assign a label to it. And it's a very simple process. So inside our next lecture we will explore RoboFlow and we will start the data annotation process for training our fruit recognition model. So see you in the next lecture. Welcome to this lecture. As inside our previous lecture, we just covered the introduction of data annotation. And now in this lecture, we will explore RoboFlow and we will start the data annotation process. So open your browser and type RoboFlow here. In the search result, click on the link which is this roboflow.com. So that's the home page for RoboFlow, and there you can see you can upload your dataset here, organize it, then annotate it, and after that it also provides the facility to train the model, and also you can deploy the model. But we will just upload our dataset, organize it, and then we will perform the annotation for training our model. And after that we will train our model using a different approach. So we will not use RoboFlow for training our model. So here, in order to use RoboFlow, firstly you need to attach your Google account. So click on the sign in. So here you can sign up with your work email, or you can sign in using your Google account or GitHub account. So I'm gonna use my Google account. So now our dashboard is open. So in your case it may look different, because here I already have a workspace, and in your case you will not have any workspace if you have logged in into RoboFlow dashboard for the first time. So here the first step is creating a new workspace. So click on the add workspace button, and then here you need to choose the category. So here we will choose it like for school, and then we will enter the workspace name. So I'm gonna enter WS2, and in your case you can name it with any name that you like. After that, if you want to include some other members inside this workspace, you can write their emails here, or you can simply skip this step. And then here there are two options. The first one is for community, and that is free. So here if you choose that thing, then you can easily upload your dataset and annotate it for free. And if you choose the business category, then some portion of this business plan is free. So we will stick with this community approach, and in that case our dataset will be available publicly, but that is not a problem for us now. So here we can choose community and click this create public workspace. So now our workspace is created, and the next step is creating a new project. So click on this create new project, and then here you need to click on this skip tutorial, and then here you can type the project name. So I'm gonna name it like fruits. And after that you need to choose the project type, as we want to annotate the data for object detection, so we will choose this project type to object detection. And then you need to add the letters, like what type of thing you are predicting. So as we are predicting fruits, so I'm gonna write fruits here and then click create public project. So now our project is created, and the next step is uploading our data. So here in order to upload the data, you can just simply drag drop the images which is present inside our folders, or you can open the Explorer from RoboFlow dashboard. So here we will simply click on this select folder, and after that we will navigate to the folder which contain our dataset. So in my case I have it inside course folder and the archive. So we can simply select this archive folder and then click upload, and it will gonna upload all the images which is present inside the subfolders of this archive. So here you can see that the uploading is started. So it will gonna firstly process all those images, and after that it will gonna upload them on RoboFlow. So let's wait for the processing to finish. So now the processing is completed, so you can see all the images. So there are total 328 images inside these 4 folders. So when you will scroll down, then you can see all those images here. So here you can also notice this annotated and not annotated tab. So all these images are not annotated, so there are 328 non-annotated images, and there is no image in this annotated tab. So we have to annotate all these images, but before that we need to upload them, and for that purpose just click on this finish uploading, and it will gonna start uploading these images on RoboFlow. So there you can see that the time it will gonna take to upload all these images on RoboFlow. So now all the images are uploaded, and the next thing is assigning those images to the person who can annotate them. As in our case, we will annotate them by ourselves, so we don't need to do anything. But if you want the annotation to be done by someone else, like your friend, then you can invite it here by clicking on this invite teammate. So you can see that RoboFlow is a complete platform using which you can not just only annotate the data, but you can perform several other useful functions, including this collaboration with team. So here for now we will click on this assign images. So here you can see annotated and unannotated images, so all the images are not annotated. Similarly, you can add specific instructions here, and you can also reassign it to someone else. And after that you can see all the unannotated images inside this unannotated tab. So here let's start annotating the images by clicking on the first image. So here we will start annotating this big watermelon. So what we will do is that keep the cursor here at this point and then press the left key. And after that, by pressing this left key, start dragging and drag it to a point so that this whole watermelon is covered inside this bounding box. So now you can see that the watermelon is almost covered, and you need to keep in mind the first point, or the first thing we need to keep in mind while annotating, that this bounding box should be pixel perfect. So we will try to do that. So here leave the rectangle here, and after that you need to assign a label to this rectangle, just as we learned that while annotating the data, we take each image and draw a rectangle around it, and then we assign a label to that rectangle based upon the object present inside it. So as this rectangle is containing a watermelon, so we will create a new class named watermelon, and we will assign the label watermelon to this rectangle. So watermelon. And after that we will click on this create watermelon class. So now this rectangle is assigned a label watermelon. Similarly, we have to do it for this little piece of watermelon. So move the cursor here and then press the left key and drag. And here select this piece and choose the class. And now you can see that we already created this watermelon class, so we can simply select it. And if the class is not there, like when we will start annotating the apple images, so in that case we need to create a new class for the first time only. So now we move to the next image. So here you can see that there are several pieces of watermelon, including this whole watermelon. So firstly, let's annotate this whole watermelon, and you can notice one thing, that this whole watermelon is not completely visible. So in that case we have to suppose that at which part of the image this watermelon is extended. So this is the part it is visible, but we will suppose it is extended at this part. So that's the case when the whole object is not present. So we have to consider that at that particular point this watermelon is present. So we will select it and choose the label. Similarly, we have to do it for all these small pieces. So firstly we will do it for this piece and choose watermelon. Similarly, we have to do it for the second piece, and we have to suppose that it is extended at that point. Select the class. Similarly, you can just also select the class by pressing enter. So here for the third piece we will suppose it and press enter, and the watermelon will be chosen. And now we will do it for a final piece, or there is also one more left. So we will select it, and then for this piece and press enter. Similarly, let's move to the next image, and it includes a lot of watermelons, so we have to do it for them. And if this thing is frustrating for you, then you can also get the annotated data, which is also shared in the course resources. So you can just take that annotated data where all these images are already annotated, and those annotations are done by me. Otherwise you have to annotate them one by one. Like in this case we will annotate this image, so we will select this watermelon for now and press enter. Similarly, we will repeat the process for each of the watermelon which is available here. And you can also skip several watermelons here, but this will gonna impact the model performance. Similarly, as I'm working on a separate PC, so my annotations are not pixel perfect in that case, as you can see, but you have to ensure that your annotations are pixel perfect. Like the bounding box should only include the object, not the corners should not be too far away from the corners of the object. Similarly, let's do it for this watermelon and this small portion. And now let's move to the next image, and there a single watermelon is present, so let's annotate it. And now let's look at the other images, and we will only annotate those which are a little bit confusing for you. Otherwise you have to annotate all these images by yourself, or you can take the annotated data. So here you can see that now 4 images are annotated, and the unannotated images are 324. So in the unannotated images, let's select this pineapple image for now, so that we can cover that how we will annotate the rest. So here now we have a pineapple, so we will try to enclose it in a box. And now we need to create a new class because it is not a watermelon and we haven't created our pineapple class. So we will name it pineapple, and we will click on this create pineapple class. So now our pineapple class is created, and now let's move to the next image, which again contains a pineapple. So we will select it, and now in the classes we have two classes, watermelon and pineapple. As we are annotating a pineapple, so we will click on them. And there is one problem you may face, and that is wrong annotation. So for example, if by mistake I enclose it here and choose the class watermelon, so as it's a pineapple, so we have to change it. So for that purpose you have to choose this drag tool from here and click on the center of this annotation, and then you can simply change it to pineapple. So now the annotation is changed. So here you can again move to the bounding box view by clicking on this bounding box, and similarly you can undo the changes using this undo button and redo them also. So it is a complete tool. Similarly, let's scroll further down and we will annotate several keywords like these. So we will draw a rectangle around kiwi part, and we will create a class kiwi here because it's not already there. So create class kiwi. Similarly, we will annotate this second portion of kiwi. Now there are three classes, but we will select kiwi here. And now for this whole kiwi which is hidden, so we will suppose that it is extended till that part of the image, and then we will select kiwi. And by that way we have to annotate the rest of the data. So now let's do it for an apple, like for this image. So here we will start the annotations of apple like that, and we will create a new class apple here. So click on this create apple class, and now we will annotate the second apple. So now you can see that we have annotated for all four classes, but we have 318 images left on which we need to perform the annotation. So you have to annotate the rest by yourself, or you can take the annotated data which is present inside course resources, and there is also a lecture which will gonna guide you that how you can take this annotated data by yourself. So if you want to do it by yourself, let's complete the annotation, and we will see once this unannotated is 0 and the annotated is 328. So let's skip to that part. So now we completed the annotation of our dataset. So there you can see that all the images are now annotated, and hopefully you have done this annotation part by yourself. And here let's look at several images where annotation is little bit tricky, like in this case where watermelon is in smaller size or in larger size. So there you can see that even we annotated this watermelon, and this annotation is not pixel perfect, but you should try to achieve pixel perfect annotation. Similarly, let's look at some of other sample images like these apples which are hanging on a tree. So there you can see that we annotated these apples which are quite clear. So you can see they are hanging on a tree and we annotated them. And same is the case with the other images. So we annotated all the occurrences of fruits, and maybe we have missed in some cases, but that was by mistake. So we should not left any part of the image where a fruit is clear and we haven't annotated it. So you should make sure that. So after annotation, we have 299 images because we have deleted several images because some of them were diagonally positioned objects. So as we learned while learning the introduction of annotation that we should not include such images, so I have removed several images from them. So here after annotation, the next step is exporting this data so that we can download this annotated data and use it for model training. And for that purpose, we need to click on this generate here so that we can generate a version of our dataset. So here you will see the information of the data you just annotated. So firstly, there are 299 images. Maybe they will be different in your case. And the classes are 4 because we are detecting 4 classes, and you should make sure that while annotating you do not create any extra class, because if you by mistake, like you have a spelling mistake, like you have apple with the capital A and apple with a smaller a, then this will be considered a separate class. So you should make sure that you have 4 classes here, and if you have like 5 to 6 classes, then you need to go inside this annotate section again, and there you have to see what extra class you created. So you have to redo that annotation. Hopefully you understand that. So here we will go to the generate again, and after that you will see this trained test split section. So here you can choose that how many images you want in the training set, how many in the testing set, and how many in the validation. So generally there are 80% in training, 10% in validation, and 10% in testing. So we have done that. And if you want to change this ratio, you can click on the rebalance, and here you can select the number of validation and testing images. So here for now we will keep them like 32 for validation, 31 for testing, and 236 for training. So click save, and after that click continue, and the next section is processing. As for now we don't want to add any processing step here, but here if you want you can change the image size. Right now the images will be of size 460 by 16 by 416. So you can here change the image size, and like you can make it 180 by 180 or any other thing. But for our case, let's keep it like that. And similarly you can explore other processing steps, like you can make the images grayscale and auto adjust contrast or things like that, but we will not do anything like that for now. And we will click continue, and the next thing should be familiar for you, and that is augmentation. So we have already looked at augmentation, that when we have less images during preparing our dataset, we can increase the number of images by applying augmentation. So in augmentation, our existing images are actually rotated or scaled, and we can increase our training images using that. So here when we will click on this add augmentation step, so here you can see there are several options, like we can rotate the image, we can crop the image and generate new images, we can change the saturation, brightness, exposure, and so on. And by using all these ways we can simply increase the number of images. As for now we have 236 for training, so what we can do, apply augmentation and we can increase the number of images. So here for now let's add this rotation. So I'm gonna click on it, and then here you can specify the angle to which the images will be rotated. So by default it's 15 degree. So when you will increase this angle, the images will be rotated. So now if we have an Apple image, then there will be 2 more images generated by applying this step. One will be rotated left by 26 degree, and one will be rotated right by 26 degree. So by using that way our dataset will gonna increase. So here let's apply the you can say the rotation with 15 degree and click apply, and now our dataset images will gonna increase. Similarly we can add another augmentation step if we want, but for now we will skip that. And after that click continue, and now here by clicking on this generate, we can generate a version which we can export later and train our model on it. So here we will click on this generate, and now this version is being created. So there you can see the version that now our dataset or the training set contains 683 images, and the validation set contains 32 and the testing set contains 31. So we need to increase this validation and testing set images, and we will do that later when we will export those images. So here you can see that by applying augmentation we have increased our images, and when you will look at these images you will see that our existing images will be rotated to the left or to the right, and you can also see that our annotations are also rotated as per our image. And the next step is exporting those images, or simply exporting this version so that we can download it and then use it for model training. So in order to do it, we need to simply click on this export button, and then here we need to select the format to which we want to export. So for our case, we will export it into a Pascal walk format, which is a popular format for preparing dataset for object detection. So we will choose this Pascal walk here, and then we will download the zip to computer. So select it and click continue, and the zip file will be generated and it will be downloaded. So there you can see that our downloaded is just started. Similarly, you can generate new version and download it. So here you can click on this generate new version, and here you can, if for example, if you want to download a new version with the size 720 by 720, so in order to do that we will change the size here. So we will click apply, and our image will be resized. And after that we will add the augmentation if we want. Like here we can remove this previous augmentation or add new, like let's try to rotate it by 90 degree. So clockwise and anti-clockwise, and we will also select this upside down, and then we will click apply. So now our new augmentation step is applied. So let's remove this previous one, and now click continue. And now here we will click on this generate, and our new version will be generated. So similarly you can generate any number of versions as you like, and then you can use them for training the model. So here our new version is generated, and it contains 565 training images, 32 validation and 31 testing. So here similarly we can export this version as well. So here choose the format to Pascal walk and download zip to computer, and then click continue. So there you can see that now the downloading started again, and here now the dataset size is increased because we have changed the image size to from 416 to 720, and we will use this second version for training our model. So let's wait for this download to be completed, and then we will analyze it. Welcome to this lecture. As in the previous sections, we collected the data for model training and we have annotated that data. And now we come to the part where we will train our object detection model using the dataset we collected and annotated. So as we know that in order to train the object detection model, we firstly have our annotated dataset, and then we will pass this dataset to our machine learning algorithm. And in our case, this machine learning algorithm will be a Python code provided by Google. So we will simply pass this dataset to that algorithm, and we will get our trained model. And obviously inside our upcoming lectures we will learn that how we will pass this data to this machine learning algorithm and train our model. So once we will get our trained model, we can convert it into a mobile compatible format, and we can also pass the testing data to this trained model and check the performance of that model. So that's the whole flow. And now we come to the part where we will pass this annotated data to this machine learning algorithm. So as I already mentioned in this course, this machine learning algorithm is a code provided by Google to retrain popular existing object detection models. So instead of training a model from scratch, we will take existing object detection models which is already trained on thousands of images, and we will retrain those models on our custom dataset, and that process is called transfer learning. So it is a very useful process that instead of training a model from scratch, we will take some existing object detection model which is already trained on a lot of data, and we will just retrain that model on our own dataset, and we will get the model we are looking for. So in our case, we can take the SSD MobileNet, EfficientDet, YOLO or other such popular existing object detection models, and we will train them on our dataset. And the output model will only gonna detect the objects which are included inside our custom dataset. So inside our upcoming lectures, these are some major things which we will learn. Firstly, we will explore Google Colab, which is a platform we will use for training our model. So we will open our machine learning algorithm code on Google Colab and pass our data to it and train the model. And after exploring Google Colab, we will get our code file which contains the code for our machine learning algorithm, and we will upload it on Google Colab. After that, we will explore the code which is present inside this code file, and then we will start the model training. And after training the model, we will convert the trained model into a mobile compatible format which is Tensorflow Lite. And then we will test and optimize that model. So these are some major things we will cover inside our upcoming lectures. So see you in the next lecture. Welcome to this lecture. In this lecture, we will explore Google Colab, which is a platform we will use for training our object detection model. So, what is Google Colab? It is a platform provided by Google to run Python code in your browser without installing anything on your PC. So we can simply open this platform inside our browser and run Python code on it. So let's explore Google Colab. So inside your browser, go to Google and type Google Colab. In the search result, go to this research.google.com Colaboratory. So click on it. So that's the homepage for Google Colab. And here we can read the details like Google Colab allows you to write and execute Python code in your browser with zero configuration because we don't need to configure or install anything. The access to GPU free of charge, and we can use the powerful GPU processors for free, and it also provides the feature of easy sharing that we can simply share the link with anyone and he can see the same notebook within seconds. So these are some major benefits that Google Colab provides. So using this Google Colab, we can run both simple and advanced Python code which will be used during data science, machine learning, or inside other resource-taking tasks. So in order to run the Python code, we can create several different cells here similar to the one here. So there you can see that simple Python code is written. So firstly we assign this calculation to this variable and then we are printing it. So here we can run this cell by clicking on this run button, and it will gonna ask you to attach your Google account with this Google Colab. And in order to do it, you can simply sign in with your Google account. So here we will click on the sign in button, and here we can add the email and the password of our Google account. So now we attached our Google account with this Colab, and there once you will sign in, you can see your recent notebooks. So now we can run this cell by clicking on this run button. So there you can see that we get the output. Similarly, we can run this cell as well, and we got the output here. And here we can add and remove these cells. Like we can click on this code and a new cell will be added. Similarly, in order to add the comments, we can add this text cell. So when you will click on this text, then this cell will be created, and there you can write the comments, and those comments may be large and small in size, and you can customize them using these properties. For example, if I write section 1 and I put a hash before it, then it will be appear like that. Similarly, if we put 2 hashes, then it will gonna be appear a little bit smaller, and when we will increase the number of hashes, the size will gonna reduce. So that's the case with Google Colab, that you can add Python cells for running the code, and you can also add the comments between those cells. Similarly, when you will scroll down, you can see this section of data science. So using this Google Colab, you can use the power of popular Python libraries like NumPy, Matplotlib and others and perform data science related operations. Like here you can simply visualize the data using a Matplotlib library which is used to plot the data and analyze it for data science operations. Similarly, you can see this machine learning section which is providing the information about machine learning. And we will be using this Google Colab for training our object detection model. So what we will gonna do is to upload our code file on this Google Colab by going into this file, and then we will click on this upload notebook and we will upload our code which is present inside course resources. But obviously we will do that inside our upcoming lectures. So see you in the next lecture. Welcome to this lecture. As previously we collected our fruits dataset and then we performed the annotation using RoboFlow. And after annotating the data, we downloaded this data. So that is our downloaded data. So it contains 3 folders, this test, train and validation. And as now we are starting the model training, so we need to firstly upload this data on Google Drive. And we are uploading it on Google Drive because we are using Google Colab for training our model, and it will be a lot easier for us to retrain the model quickly once we have our dataset on Google Colab, because our Google Colab will gonna access the data from Google Drive very easily. So open your browser and go to your Google Drive. So I'm gonna type Google Drive. So click on this My Drive. So now here inside this My Drive folder, we will create a new folder. So right click on it and create this new folder. And we will name this folder fruits, and you can choose any name that you like, but later inside our code notebook you have to use this folder name. So it's better that you name it like fruits. And after that just click on this create button and this folder will be created. So there you can see our fruits folder. So now let's open this folder. So now here inside this folder we will upload our annotated dataset. So here we have our dataset folders. So I'm gonna select all these 3 folders and we will leave these 2 files. And I'm gonna drop them here. So there you can see that the uploading started. So why we are uploading our data on Google Drive? The reason is when we will use Google Colab, we will create notebooks there. A notebook is a simple Python file created on Google Colab, or it is also created on Jupyter Notebook, which is also an IDE or platform for running Python code. So here whenever we will run our code, a session is assigned to that code, and whenever that session expired, all the data that we uploaded in that particular notebook will be removed. So here inside this Google Colab, we can also upload our fruits dataset, like we can paste it here. But once our session will be expired, that data will be deleted. So it means that in the next session, like tomorrow, we have to upload it again. So that's why in order to save the time, and also in order to save and in order to avoid the problem of uploading the data again and again in case we want to train the model multiple times, we are uploading it on Google Drive, so that our data is already there on Google Drive and we don't have to upload it on Google Colab again and again. So that's the reason why we are uploading our data on Google Drive. So now let's wait for the data to be uploaded. So now the dataset is uploaded successfully, and there you can see all these 3 folders: test, train and validation. And inside our next lecture, we will upload our code notebook on this Google Colab and we will start training our model. So see you in the next lecture.